Okay, so welcome to 1.5. Now we're looking at our third type of quantitative data display, which is the histogram. And I'm going to be 110% honest. This one is probably my least favorite. Like graphically, very aesthetically pleasing. Constructing wise is very tedious. So it's more common for you to have to describe histograms and know how to compute the summary statistics from them. And you would still need to be able to do those few things also for stem plots, dot plots, and box plots. However, the other three types of display are a little bit more user-friendly when it comes to creating the display. Nonetheless, this is AP Stats, and we got to make sure we know how to do it all. So, for histograms, we're going to use this one, this type of display for large data sets and, again, for quantitative variables. And when I say large, I really am thinking like n is greater than or equal to 20. I think less than 20, a stem plot and a dot plot is easy to navigate. Once you've got more than 20 observations, you have to start using intervals. And that brings us to our next thing, is that the scale for histograms is done using intervals. And it's done using the following interval. And since we are all proper mathematicians, we know that this includes the left-hand endpoint and then is open on the right-hand endpoint. And we'll talk a little bit more what that means in the example. Of course, you need a title. Your x-axis is going to be your variable versus your y-axis, which is going to be your frequency. Now, histograms are very similar to bar charts, except bar charts deal with categorical data, histograms deal with quantitative data. So another important factor is that there's no space between the same sized bars. This basically, it's like if it were a bar chart, but it all squished together. We know that the only time the bar width is different is when you're dealing with the mosaic plot, which takes into account the sample sizes of your sample. So these are just a few key points on dealing with histograms. Now, you can find all the summary statistics from a histogram. However, we're really going to be focusing on the range and the median again, since those are the quicker ones to go through. And also, a big thing with histograms is that since we are using intervals and we're saying like it's in between these values, we need to make sure that we include the word approximately, approximately, when we are doing our analysis of a histogram. And that's because sometimes we will have all the data, sometimes we won't. Most times we're just given the graphical display and just asked to analyze that. And since we only know the intervals, we'll never know the specific summary statistic unless it's either given to us with a table or we're given the data and asked to construct that. So we just have to be sure that we include the word approximately, because with dot plots and stem plots, we were able to see all the data, which is how we were able to display it. Histograms, it's either or. For the purpose of this example, we will be constructing a histogram, but I'll kind of show you the process that we go through to make this happen. So, it appears that El Nino, the periodic warming of the Pacific Ocean west of South America, affects the monsoon rains that are essential for agriculture in India. Here are the monsoon rains in millimeters for the 23-strong El Nino years between 1871 and 2004. And this just comes to us from the practice of statistics. I had my students do a dot plot and stem plot. I'm realizing now I'm a meanie for trying to make that happen. So, hi everyone, guess what? We're going to do this using a histogram. So your first thing is going to create the frequency table. So I could line all of these up in chronological order and get right to it. We're going to just take a little bit of a more simple approach to that. So I'm looking at these intervals, and let's see, 628 looks like my smallest or my minimum, and 957 looks like my largest or my maximum. So that's definitely going to play a role in the intervals that I create. Like I said, you won't always have the data. Here we do, so we can actually compute it, but we're going to practice as if we did not. So my first interval, looking at 628 here, let's see, I can start at 625 and then go up by increments of 25. That to me seems really tedious. So I'm just going to give myself a little bit of grace here. And I'm going to do the first interval, which would be 600 to 650. So that's going to be my first one. And remember, like I said, this would include 600s up to 650. The next one will include is going to be 651 to 700. Oh, I had a brain fart there. Okay, I did make a boo-boo because this should have been 650 because this bar would include the, you know what? Fine. You guys pulled my leg too much. There we go. 650 to 700. So this bar would include 650. This bar would not. Okay, then the next one we're going to do is 700 to 750. Okay, Lord, these lines. My bad, y'all. 750 to 800. Okay, we're getting a little better. 800 to 850. 850 to 900. And then 900 to 950. Oh, my Lanta. Oh, here we go. 950 to 1,000. Okay, so now I'm just going to go through and do the frequencies, which means how many of these values fell in between 600 and 650. So it looks like 628 was one of them. You know, I'm just going to do a tally system here. This is what teachers go through. 669 would be in the second category. 740 is going to be up here. 651, 710, 736, 717, 698, 653. And as you can see here, I'm literally just checking out. Oh man, another boo-boo. This was actually my minimum. Okay, I'm a liar. And a terrible line drawer. You know, it's just not looking good for me. 604 is out. 781 we'll put in here. 784 in this interval. 790. 8 to 11. 830. 858. 858 again. 896. 806. 790. 792. 957 and 872. Okay, so this is just my frequencies. This just means how many values occurred in each of these intervals. So now I'm actually going to create that display, and I'm actually going to do it a little bit lower just to give myself some work room here. So again, we're going to start with our scale, and our y-axis is going to be our frequency count. So let's see, 1, 2, 3, 4, 5, 6. Did I have any more than that? Nope. So I'm going to label my y-axis as frequency. My x-axis is the amount of rain in millimeters, I believe. Amount of rain in millimeters. Now my scale, I'm just going to skip a few. I just put a few dots here and start my scale here at 600. 650, 700, 750, 800, 850, 900, 950, 1,000. So I've got my scale, I've got my axes, I've got my variable. I need a title, and we're just going to call this monsoon rains. Again, you can get as spicy as you want. I'm giving a brief overview. Okay, so in this first category between 600 and 650, I had 2 observations occur. So I'm going to draw my bar here. Oh, you know what? It's okay. We'll work on it. Between 650 and 700, I had 4 observations. So I'm going to 1, 2, 3, 4. And up to you how you want to do this. Because the frequency chart is here, you don't have to write the numbers above. You can if you want to. And 700 to 750, I also had 4. And I'm trying my best here to make sure that my bars are approximately the same width. Between 750 and 800, I had 5. So, and that little extra fun there. Between 800 and 850, back to the 4. between 850 and 900 also. Oh, I made a poo-poo. It was 3. It was 3. Okay. Here we go. I'm just going to scratch that out. You all see, I'm giving you raw behind-the-scenes footage. There we go. So it should have been 3. Then the next category should have been 4. Looks like we have a gap there, and then one lonely guy down here. Okay, clearly histograms are just not my thing, but we're trying to make it work. So, this would be my graphical display for the histogram. Now, it's not very pretty, but I think it gets the job done. To find the median, again, we are going to need our sample size, and we were told here that the sample size was 23. Which means if I wanted my median, I would do my n plus 1 divided by 2 magic here, 23 plus 1 divided by 2. Got the 12th observation. So this is where the frequencies come in handy. In this first bar we had 2. In this next bar we had 4 and 4. So my median occurs at the 12th. So 2 plus 4 plus 4, that gives me 10. Not going to be in there. But in this next bar I had 5 observations. So between these first 4 bars, the first 10 observations occur here, and then 11 through 15 occur here. And if I'm looking for 12, that means my median is going to be in this category here. So I would say that my median is approximately between 750 and 800 millimeters. Again, and that squiggly just means approximately. If I didn't have the true data, I would just be approximating where it is. Now, the range, again, a little bit tricky because this is an interval. So I don't know if this one lonely number is 951 or if it's 999, 987. You get the idea. I don't know what it is. I just know there's one number in here. But I do know the max potential of that one number is 1,000. So I'm going to use 1,000, and I do know here on my left-hand interval, the smallest possible number it could be is 600. So my range, and again I'm going to put approximately 400, my range is approximately 400 millimeters. Again, I have the true data, so I could find the actual range, but we're just approximating. And just to prove to you I'm not a liar, let's look here at, see I was trying to draw it in there, 957 minus 604 is about 353. Not close, not super close to 400, but approximately 400 depending on who you're asking. And then lastly, shape gets a little bit tricky. If I were to just to draw what I think is happening here, I would think this one extreme value would pull my average towards it. So if I notice this gap here, if I were to cover this gap, I would think that this distribution looks approximately symmetric. But because of this one potential extreme value, I'm thinking the average could tend towards it because the average is a non-resistant measure of center. So I'm thinking that the shape for this type of data would be skewed to the right. And my wiggle word for the shape, because I can't say approximately skewed right, it either is skewed to the right or it's not. I'm going to say appears to be skewed right. So that's how we finagle when it comes to the shape of a histogram. So again, we found the median by adding up the frequencies. We still used our formula and found the position or the interval of where we think the median would be. We found the range because we know it can't be any more than 1,000 and no less than 600. So you can say the range is approximately 400 or no more than 400. And then the shape, because we still need a wiggle word, we said appears to be skewed right. Because this could actually be skewed left, depending on what interval you use. But based on our display, it appears to be skewed right. So that's just a little bit on how we work with histograms.